In this optimization problem, we're finding the dimensions of a rectangle with a fixed area that has the smallest possible perimeter. The first step in solving this problem is to read through the problem carefully and figure out what information we're given and what we're asked to find. We want to find the dimensions of a rectangle with area 8,000 meters squared, whose perimeter is as small as possible. The second step that we're going to do is we're going to fill in these four categories using the information from our problem. I already went ahead and wrote down our diagram, which is a rectangle. Now we have to put variables with our rectangle. I'm going to let this length be x and this be y. Now we need to identify these variables. So we're going to say that x is the length, and then y is the width. Now what we need to do is we need to find an equation that relates these two variables. We are told that the area is 8,000 meters squared. So the equation needs to be an equation for the area. So we're going to write down that A is equal to xy, and that is equal to 8,000 meters squared. Now let's determine if we're going to find a maximum or a minimum. Our problem tells us that our perimeter needs to be as small as possible. So that means that we are going to minimize the perimeter. Let's write down the equation for the perimeter. The perimeter is all four sides, so it is going to be 2x plus 2y. Now what we need to do is we need to write our equation for our perimeter in terms of one variable. I want to write it in terms of x, so we need to find an equation for y in terms of x. We're going to get that from this equation right here, and we can say that y is equal to 8,000 divided by x. So let's go ahead and let's put that in. P is 2x plus 2 times 8,000 divided by x. Since we need to minimize P, we need to take its derivative. So at this stage, what we need to do is we need to write P in the easiest form possible to take a derivative. So I'm going to write P as 2x plus 16,000 x to the minus 1. Now let's think about our domain. We are given no constraints on our length x, but we know that a length can't be negative, and it also can't be 0 if we have an area of 8,000. So let's write down that x has to be greater than 0, and our domain is open. We'll need that in a few minutes. In our third step, we're going to take the derivative of the quantity that we are going to minimize. So I'm going to go ahead and let's highlight this. That's what we need to take the derivative of. Let's go ahead and let's copy it down. P is 2x plus 16,000 x to the minus 1. Now we can take the derivative. P prime is equal to 2 minus 16,000 x to the minus 2. We need to set this equal to 0, so let's go ahead and let's simplify this first. This is 2 minus 16,000, all divided by x squared. And now we can get a common denominator. That's x squared. So we have 2x squared minus 16,000 in our numerator. I'm going to go ahead and highlight this because we're going to need this in a little bit. Now what we're going to do is find our critical values. So we're going to take our derivative and set it equal to 0. This gives us 2x squared minus 16,000 is equal to 0. I want to make a note that x is in our denominator and could be a critical value at 0, but our function is not defined at 0. So it's not going to be a critical value. So we're just going to look at where the numerator is equal to 0. So this gives us 2x squared is equal to 16,000. And this gives us x squared is equal to 8,000. Now we're going to take the square root. X is the square root of 8,000. We can pull out 100 from this, and the square root of 100 is 10, so we can write this as 10 times the square root of 80. And then let's think, 4 goes into 80, so we can pull out a 2. So this is 20 times the square root of 20. And then the square root of 20 is 4 times 5, and we can pull out another 2. So our x is going to be 20 times 2, which is 40, times the square root of 5. And now let's put units on it. We are working in meters. So we found that x is equal to 40 root 5 meters. Now let's go ahead and solve for y. I'm going to do that over here. Y, let's go back up to the top, is 8,000 divided by x. So y is equal to 8,000, all divided by 40 root 5. 40 goes into 8,000 200 times, so we have 200 divided by root 5. And now let's go ahead and let's get rid of the root 5 from the denominator. So what we're going to do is we're going to multiply by root 5 and divide by root 5. So we're going to get a 5 in the denominator. 5 goes into 240. So we end up, let me erase our equal sign here and put an arrow. So we end up with y is equal to 40 root 5 meters. And let's go ahead and highlight that. Notice that x and y are the same. So let's just make a note that our rectangle is a square. Now, it may feel that we're done, but we're not done yet. What we need to do is we need to find the minimum perimeter. So let's go ahead and let's solve for p. Our p is given up above as 2x plus 16,000 x to the minus 1, but it's also written up above as 2x plus 2y. So I'm going to use that form because it's easier. Our perimeter then is 2 times x, which is 40 root 5, plus 2 times y, which is also 40 root 5. So we end up with, let's see, 80 plus 80 gives us 160 root 5, and then we put in a unit of meters. And let's go ahead and let's highlight that. In step 4, we need to justify that our answer gives a minimum value. Because our domain is open and our derivative, let's see, I highlighted that in blue, that derivative is pretty complicated. So I think we should use the first derivative test instead of the second derivative test to justify that p is a minimum. So let's write this down. We're going to use the first derivative test. And I'm just going to put p prime here because we're going to need that. P prime is equal to 2x squared minus 16,000 all divided by x squared. To do our first derivative test, I'm going to put a number line, and this is going to be x. Let's indicate that x starts at 0 but is not equal to 0. And let's go ahead and put our critical point on here, which is 40 square root of 5. Now what we have to do is find the value of p prime to the left and right of this point. All we need to do is find if it's positive or negative. So let's go back over here to our derivative, and I'm going to highlight just the numerator. The denominator has a squared term, so it's positive, so we don't need to really worry about that. 40 root 5 is where what I've highlighted in orange is equal to 0. So that means that to the left of 40 root 5, p prime is going to be negative, and it's going to be positive to the right. Now let's think of this in terms of increasing and decreasing. If p prime is negative, our function is decreasing, and then it's increasing, and that tells us that we have a min. So I'm going to write down that we have a min at x is equal to 40 root 5, and p is equal to 160 root 5 meters is a minimum. And let's highlight that. Now we're almost done. Our fifth step is to reread the problem and carefully state our final answer in a complete sentence. Let's go back up to the top. Our problem says that we are to find the dimensions of the rectangle, and our dimensions are length and width. So let's write down that the length is 40 root 5 meters. We always want to make sure and include units in our answer. And the width is also 40 root 5 meters. And we'll highlight this because that is our final answer.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.